Thank you. Welcome. Welcome. Thank you very much. Welcome. Welcome to Perimeter Institute. Welcome to our public lecture series, and welcome to the Mike Lazaridis Theater of Ideas. My name is Greg Dick. I'm the Director of Educational Outreach here at Perimeter, and it is a pleasure to welcome everyone here this evening. Those of you here in the theater, and of course those of you watching online. The lecture itself will last approximately 1 hour and will be followed by a question and answer session. And for those viewers watching online, Dr. Damien Pope and a team of PI researchers are behind their keyboards ready to engage in conversation throughout the lecture. If you want to participate, use hashtag #PILive. And also, for those of you online, if you want to ask a question of our special presentation presenter today, use the hashtag #PILive and get those questions in relatively early so they can make it all the way to my phone. And now it is my pleasure to introduce today's very special guest speaker, Dr. Clifford Johnson. Dr. Johnson is a professor in the Physics and Astronomy Department at the University of Southern California. Professor Johnson's research focuses on developing theoretical tools to describe the basic fabric of nature. He and his team are trying to understand and describe the origin, the past, present, and future of our universe. In addition to his research, Dr. Johnson is passionate about sharing science with the public. He's not only a public speaker, he is also a science consultant on TV and movies. He's an avid blogger and an author. Dr. Johnson's desire to write an engaging book that turned complex scientific ideas into compelling visual narratives resulted in a graphic novel titled The Dialogues: Conversations about the Nature of the Universe. Ladies and gentlemen, please join me in welcoming Dr. Clifford Johnson to discuss the scientific ideas portrayed in his book and how he came to write and draw a graphic novel. Dr. Johnson.
Thank you. It's a real pleasure to be here, and I have to say, it's such an amazing series, so it's an honor to be able to contribute in some way. So today's talk is maybe going to be a little bit different from what you're used to, because it's part of a series that's about public engagement with science, and I'm going to actually be talking about the business of publicly engaging the audience with science. So in some ways, it's a little bit meta, perhaps, a little bit more than perhaps you're used to. But let's go anyway and talk about the mission. So the key thing here is that I feel that it's a remarkable privilege to be part of a society that is structured in such a way that someone like myself can devote their life to doing research on esoteric things that perhaps don't have any real application, just for the sheer curiosity of it. And so I feel it's a duty to give something back. And there are many different ways scientists do that, under the banner of outreach or public education or, as I said, public engagement. And there's a whole variety of them, and together I think they form a wonderful sort of network of different kinds of things that we do, that we can engage in different ways and different amounts depending upon our tastes, that can really help get people excited. Why do we do that, other than I feel that there's a duty to do that, but I also feel it's hugely important. I feel we don't really truly live in a democracy if we leave science to just, the quote-unquote nerds or the experts or the people in closed rooms making big decisions about our lives in the name of science, because science intersects with so many aspects of our lives. And so it is also political in some sense, that we need to be, as part of the citizenry, engaged with science. It should be part of the general culture in which we engage. So a lot of what I do is under the banner of putting science back into the culture where it belongs, rather than having it sort of sidelined as a sort of special interest group, as it were. So that's the mission. And I really sort of have this belief that people wherever they are, whether it be out in the world at a bar or at a cafe or I don't know, at a party or something, that you can chat about science just like you chat about any other topic that might be engaging in the moment, and you'll see the whole business of conversation coming back in a big way as I go along. So yeah, it might be that you're out there in the world, maybe at a train station, what have you. I want to feel that all these people are part of, or at least feel welcome into the conversation about science. So how do we do that? Typically, an academic like myself might do something like do a demo in a lab. People come to us, maybe a museum, or give a public talk like this, where there's a huge amount of control that you have as the scientist doing that. You control the whole content. And you have a good, hopefully good-sized audience, and that's really great and very important. And if you like, that's part of the sort of very traditional way of doing outreach and engagement. But there are other things that can be done as well, and sometimes I get involved in those, like on some TV show, you might be part of a documentary where you're a talking head of some kind. If maybe do some fun demo kind of thing. The key thing there is that you give up some control. You have a filmmaker that is asking you to appear. They slice and dice what you say in various ways. You have no control over that. You hope that some coherent bit of science gets across. But the payoff is that you reach a much larger audience. So that's another important aspect of reaching the masses, as it were. There's another one which is a little bit more unusual, but I think growing and also very important. You give up even more control and maybe do some advising, as I sometimes do, working with filmmakers and people who make feature films or TV shows. These have huge reach, millions of viewers, but you have even less control. You have no idea what's going to happen with some of the content you give them, whether it's going to be used or not. But just sprinkling in just a little bit into people's everyday lives where they're not expecting science to be can be really can have a huge impact. So unfortunately, each of these different ways of doing things is a separate talk unto itself. I'm not going to talk about that, but I just wanted to sort of lay out the landscape. What I am going to talk about is books, because that's another place where we have a lot of control, and it's something that's part of sort of the traditional outreach. But the takeaway from what we're going to do, what I'm going to talk about today, is really to say that the standard book that we tend to do as academics it's a wonderful thing to do, and we should keep doing it. But I really think that we can do much more. I think we can broaden the kinds of books that we offer a very diverse audience. Not everyone likes reading books in one different kind of way or one type of book. So we should really offer more. And scientists are supposed to be very innovative people. So part of what I'm trying to do is innovate and encourage others to innovate as well. So that's where we are. So the idea. So let me start by just reminding you. Okay, there's a book. Okay, and just to be on the safe side, I put an extract from one of mine, and yeah, what is it? It's words, and that's wonderful, and that's typically what people have in mind when they think of a non-fiction science book. And as I said, there's nothing wrong with that. I think those people should continue writing those books, and it's really wonderful. It's a wonderful resource for people who are inclined to seek out those kinds of books and read in that sort of mode. But there's something that always struck me, especially when people were asking, when are you going to write your popular book? One of the things that always struck me was that those books have a certain sameness to them, in the sense that there's a monologue from the expert telling you about perhaps the latest developments in the field and maybe about some of their research, and that's wonderful. But that's not for everyone. And in fact, in some ways, I think we miss out on a huge amount of people who would be excited about science if they could find the right way in, and this isn't necessarily the way in for them. So I was thinking about what I might offer in terms of writing a book of my own, and I decided there wasn't any urgency to produce that sort of standard kind of book. And so for a while, I sort of drifted in and out of the idea. And then one day I hit on something, which is that one thing I'd like to change is the point of view. And wouldn't it be interesting if we could celebrate something that I hear going on around me all the time, and that is people actually having conversations about science. And I sit in cafes and all sorts of, trains and buses and things, and I hear people talking about all sorts of topics, and sometimes those topics are about things that are going on in the news of science. So wouldn't it be interesting to celebrate some of those conversations and to actually have them represented in some book form, because I think it could be very valuable. It would also invite people to have conversations of their own, and also by eavesdropping on these conversations, you might pick up some science as well. So that was sort of the germ of the idea. And then I realized that actually this is an old form that people have largely forgotten, at least in my field. You may or may not know, but when Galileo was trying to tell the world about some of his core discoveries that led us to realize that, the Earth goes around the sun and so on and so forth. That wasn't in some learned paper that was in a journal somewhere for other experts. That structure actually didn't really exist yet. What he actually wrote were the equivalent of the popular books of the day, and they were in dialogue form. And so in some sense, what I was hitting upon was the idea to do some modern dialogues and have it be peopled by ordinary, regular people, as opposed to, wearing togas on a mountaintop or something like that, which is what you have when you think of the sort of Platonic, Socratic sort of dialogues. So that was the idea. And so my thought then was to go ahead and write some dialogues, and maybe every now and again have an illustration or two. And so that was the idea. That was about 20 years ago now, and then I sat on it for a while because exciting things were going on in my field of string theory and field theory, and I was working on those things. But the idea sort of grew, and it really became important to me that we should do something else which we're discouraged from doing in science books, which is actually to show some of the things that we use as real scientists, to show equations, which is supposed to be, oh, you're not supposed to do that, and things like that. And the idea there was that I think that if you do it in the right way, you can have equations, you can show equations, and you can show the tools that we use when we do science. It seems really weird to me that we're encouraged to use as few equations as possible, preferably none. It's sort of like writing a book about music practice without ever showing a musical instrument or something like that. And so it seemed to me very important to be able to do that and have people be comfortable with it as well. So that was sort of the idea. So I thought it'd be fun to have a few illustrations and not be shy to sort of show, if you had a conversation, you might be scribbling on napkins in a cafe somewhere, and some things come out, maybe some diagrams, maybe some equations. Show that at the end of every conversation. So that was the book idea. But I would shelve it and come back to it, and as over time, the idea grew, and I wanted to show, like I said, some more tools of our trade. I gave a talk here earlier, a technical talk to my audience. You can see, to my colleagues, and you can see there's a huge amount of visual components in here that we use as our tools for thinking about physics. And it seems ironic to me that we're encouraged to hide that visual side and just explain all of the ideas in words. So that meant that in my mind, more and more, the visual side became potentially more and more important. But I still hadn't really hit upon what I was doing yet. I was sort of still playing with the idea. Until about 2005 or so, I began to think, well, wouldn't it be interesting also to see who's having that conversation? And so maybe I could just depict who those people are and maybe show, where they're having that conversation. That might draw you in, because as a person, as people, we're intensely interested in other people, I find. You're sort of seeing what other people are doing. So you might see some people talking, you might be wondering, well, what are they talking about? How did they come to meet? Things like that. So that might be a way of bringing people in to listening in on the conversation. So that was the idea. And then I thought, well, let's also have those people be placed somewhere out in the world. That has the added advantage that you're showing that science isn't just the province of a special environment like a seminar room or a special lecture theater or something. It's out there in the world, going on in people's minds all around us. So have it do that in this book. And so I got a bit carried away and started imagining all sorts of environments that this might take place in, and thinking of characters. And yeah, I got very carried away. And then it became the book that was mentioned. So what I want to do now is tell you a little bit about the book itself, give you a few examples of how I go about achieving the things that I just talked about, and maybe because people are always curious about how you actually make a book like this, also tell you a little bit about that. So that's where we're going next. So the book. So first of all, let me just say a couple of key things about what's going on in terms of the elements that come together. So of course there's pictures. The word graphic is in the title of the talk, and you've heard it's a graphic novel. And what does that really mean? So there are pictures, and of course there are words. I haven't dispensed with all of the words, so there's also words. But very importantly, there's also what I like to call symbols. And now symbols can be themselves words, or they can also be pictures of people. They can be any sort of element that immediately inspires a certain kind of concept because of popular usage or usage in context. And so symbols, words, and pictures go together in a way that support each other and become extremely powerful tools and achieve things that no single one of those things on their own can really achieve. And that is the power of the graphic novel form. That's often just regarded as this thing that kids read, but it's in fact one of the most powerful media for communicating ideas that has ever been invented. And then together, they form a narrative that really sort of moves forward and helps propel whatever message you're trying to get across. So I think it's a very well-suited medium for discussing ideas, serious ideas, not just sort of jokes and giggles, although jokes and giggles are fun, but serious ideas. And so I could say a lot more about that. Let me instead point to some great sources in case you're interested in learning more about what the language of graphic novels can be. These are the first two are a couple of classics by Will Eisner and Scott McCloud. I strongly recommend them. But let me also very strongly recommend what I think will be a new classic, Why Comics by Hilary Shute. And which came out last year. It was a New York Times notable book, and she really unpacks a huge amount of other aspects of the language and power of graphic novels that these books don't necessarily talk about. So I think one of these would be a great way if you're interested in learning more about that triangle I was telling you about. But let's talk about the book. So yes, in the book you will see people having conversations, as I promised. The title of the book is The Dialogue, so what you're doing is you're eavesdropping on dialogues between people. I originally had it would just be the same two people talking and then different topics, but eventually I sort of branched it out and had many different people, different pairs of people intersecting sometimes and talking in various ways in different settings. So yes, you're hopefully drawn in, and you're wondering who these people are and how they came to meet and what might happen. Like I said, I then feel free to have equations be part of the story in what they're discussing. And in fact, there is one story where they actually talk about that. This particular character says, well, I love science, but when the equations start showing up, it all gets messy. And he responds, well, no. Let's work with that. Let's talk about that. Why do people run screaming when you talk about equations? You don't do that if you're in an art museum and you're looking at a painting. You don't know the whole history of art and all of the language that went behind producing that painting. But still, you appreciate what you can, and maybe the next time you visit, you get a little bit more. And so his idea is that we should treat equations the same way. You should appreciate that, yes, there's a whole bunch of stuff there that you don't understand, but get what you can, and that's okay if you don't get it all. But somehow our culture is such that when it's math, you're supposed to just shut down. So let's not do that anymore. So that's sort of one of the things that comes up in this particular conversation. One thing I will say overall is that so here are some other interlocutors, if you like, chatting. One thing I will say is that you have several opportunities to see different kinds of conversations. I also like the idea that you don't necessarily have to read the book in sequential order. You can just jump in and get some things out of it and then step aside. One of the other things I realized that was incredibly powerful about going to this medium is the fact that conversations don't necessarily have a particular signpost saying what they're supposed to be about. And actually, that's really good. Conversations sort of ramble. You started off here, but you ended up over there, conversationally. That's great because science is interconnected. So I can also use those conversations as a way of showing the connectivity of ideas that normally wouldn't be joined up in a sort of nicely demarked standard book. So that was something else that was really nice. But then the other thing I want to show you, and I'll do it by example, is that you can have several different levels of things going on the page. This is what separates comics from, in people's minds, comics or sequential art, if you want to be pretentious, sometimes I'm pretentious. People sometimes just think of them as movie stills. And it's kind of a movie, but it's just a bunch of stills. And that's just wrong. In fact, when people heard I was working on a graphic novel, they think, oh, you're doing that because one day you want it to be a movie. And no, that's something different. It's a different medium with its own strengths. And there's incredible numbers of levels of things that can go on at the same time on the page, which can be very powerful for communicating ideas. And I'll try and give you some examples. Well, here we have one already. This is just a series of panels that assemble together into a whole picture, and this is in the middle of a conversation, so you don't need to figure out what's going on here. But I just wanted to give you an idea of there's the real environment of those people in a space somewhere. You saw them earlier. They're chatting. But I can also use some of the things that are in the space as my own sort of chalkboard to put some of the things they're talking about. So they're not really seeing this per se, but it's sort of there in a sort of imagined way, if you like. You, the reader, can then engage with what they're saying, engage with them as people in an environment, but also engage with the abstract things that I've put down, in this case even including equations, which you may or may not get, but you sort of have a sense of the context. So that's the sort of multi-level thing you can have going on. Here's another one where one character had actually gotten out a notebook and was actually trying to show another character what some very famous equations following from Einstein's theory of gravity is all about. And so she's actually physically writing some equations there. So she's, again, there's multiple levels going on there. She's actually engaging with her own environment and showing an extra level of the science beyond just talking about it. This character here is engaging with a very exciting concept which you may have heard of, which is the idea that in trying to understand a quantum theory of gravity, it's still one of the great quests going back to the 20th century into the 21st, of trying to understand what's the correct description of gravity at the quantum level. We need that in order to understand the interior of black holes or the very early universe, to understand our origins. One of the ideas is that the space and time that we live in, which is sort of this nice, sort of well-behaved, gently curved, according to Einstein, environment, it becomes extremely disrupted at the quantum level, to the point where you can't even describe it in terms of a sort of smooth object that you normally describe gravity in terms of. So what replaces it is one of the questions. And one of the ideas is that maybe in some understanding of the quantum theory of gravity, there's a sort of quantum of space-time, if you like. There's another description of space-time at the quantum level, which is very different from the space-time we're used to. And the analogy is water. We have water, it's sort of smooth and sloshes around and has fluid properties that we all intuitively understand what that is. And so that's analogous to space-time being the smooth thing that maybe gets bent, according to Einstein, representing that sort of fabric of space-time that gets bent by mass or energy and allows light to bend. You've probably seen those sorts of pictures. That concept is sort of the water is to that description of gravity, the analogy there. But what happens at the quantum level? Well, at the quantum level for water, we know that there's a whole other description, which is in terms of molecules. And molecules don't know about wetness and fluidity and all of those sorts of things. But we do have a very firm understanding of how you go from that molecular description of water, which is useful for understanding some aspects, to the fluid description, where you don't care about the molecular thing. So maybe in the quest for quantum gravity, there's a molecular understanding or completely different variables, as we would say in the field, that's the analog of the molecules of water. That's what that part of the conversation is about, and she's just sort of engaging with it in a very straightforward way by picking up her glass of water and splashing it. And so, again, it's an incredibly powerful thing to be able to do when you have the visuals at your command, which is perhaps less easy, much more straightforward. Much less straightforward if you're just doing a prose book. So moving on, here's another thing which I really love talking about, and many of you will know what this is. This is a Feynman diagram, and I just revealed the parts of it in the order you might traditionally read the comics of a panel, that way, that way, that way, that way. And what I did is I took a Feynman diagram and I draped these comic panels on over it, and that happens somewhere in the book. And the point here is that if you read it as though you're reading a comic, you will reconstruct what actual working scientists do. There's a narrative there that a Feynman diagram is, and working scientists use this. This is probably the most powerful tool in the history of science. With this, you can calculate more accurately and test it to the 15th decimal place than any other tool for calculating. In science, by combining Feynman diagrams, which are a little visual narrative. And what is it? It's a cartoon. So if anyone ever tells you that cartoons are for kids and they don't really have a place in serious discussion, just remind them that the most powerful tool in science is basically a cartoon. It's a Feynman diagram. And all I did is I just lifted it and put it into the context of a comic, but actually it has an existence outside of that context, where we, for example, describe the atoms and electrons and the constituents of the nucleus of an atom in terms of protons and neutrons, and in the constituents of protons and neutrons in terms of various kinds of quarks, and how those things interact. They interact via various forces, for example, electromagnetic force, and the key thing you use to model that in most of the science we do at that level is the Feynman diagram. So it is a working tool for working scientists, and it's already a cartoon, so it seems very natural to me for it to be in this sort of context. And I'll say more about that later on. Here's an example of the use of symbols. Right? In the context that we're in this building, where a lot of people work on aspects of gravity, you just show a tree that looks sort of like an apple tree, and you immediately know it's gravity. So this is a great example of how a whole picture can itself be a symbol. And then here's another symbol, which is the business of computing with the Feynman diagram. And here's another familiar symbol, which is just a cross sign. This is part of a discussion that actually isn't in the book about the failure of trying to model gravity at the quantum level by just using Feynman diagrams. And that leads to people to try other things like loop quantum gravity or string theory or other approaches to understanding gravity. Here's another symbol, which is that you have a notebook with a big question mark, and that's definitely code for we need to figure out what the right answer is. What do we do next? So combining symbols in various ways can be extremely powerful for trying to understand, for trying to communicate some of the quest that one does in doing science, as well as the science itself. Here's another example that this comes from the whole quest to understand some of the suggestions from approaches like string theory to understanding our universe, where you have this two-dimensional representation of our world, as it were, and then someone looks, if you could look closely enough, maybe you would discover that there are actually extra dimensions. And so that's meant to represent our, for example, our three spatial dimensions. But if you move in an additional hidden direction, you can find that there's room that way, maybe another sheet, that's maybe another universe, and so on and so forth. What's the symbol here? The symbol here, the key symbol here is to look closely enough. We're not going to do it with a magnifying glass, right? Maybe one day with a powerful enough particle accelerator, we might find hints of that sort of structure or not. We still don't know. So this is code for that whole enterprise of looking closely by using particle accelerators. So again, the power of the image as part of the narrative can be extremely evocative. So let's move on a little bit. I'm going to give some other examples. This is symbol, or if you like, it's more visual metaphor. So this is part of a discussion about that idea you hear a lot about, which is the theory of everything. Maybe one day we'll find the perfect equation that will describe all phenomena, and then we just go home or just go and sit on the beach, and we're done. All of science is over, or whatever, however it's usually pitched. There are those, including this character, who questions whether that's actually the way it will end up. And her view is that the whole history of science suggests that maybe that won't be how things end up. Instead, maybe the theory you find and think is the theory of everything is always provisional in some sense. The refined idea is that you have a framework. You find whatever it is. The standard model of particle physics right now is our best understanding of what everything's made of. And if you ask the right questions, it'll answer it for you. But there are questions that it fundamentally cannot answer. So, for example, there's the particles that make our kind of matter up, the up and down quark, the electron neutrino. Those all form a family of particles that all work together, and the universe could have been just fine with just those particles. But it turns out that there's another family of particles that are just like these ones, but a little bit heavier. The electron is replaced by the muon. There's a muon neutrino. There's the strange and charmed quark, and they form what's called a separate family. And then there's another family on top of that, which are even that bit heavier. And the thing is that the standard model can describe all of that, but it won't tell you why there are three families. So that's a great example of what could be, for the purposes of argument, a perfectly good theory of everything. But it's a theory of everything so far. And so that's what she's saying. So in that description, you have this box, which is a nice placeholder for the whole thing. And then you have this visual description, the theory of everything so far. You maybe missed the label. And then what happens next? Well, you might begin to ask, what are the answers to those other questions? And the only way to do that is to put that into a larger box, which now becomes the theory of everything, but for now. And her argument is that maybe that process carries on forever. And that's a perfectly respectable outcome, and it's still very interesting because each of those different boxes can be intricate and beautiful and have all kinds of interesting and amazing structures and wonderful vistas they'll take us to, but the series of boxes maybe never ends. And so that's a nice example of illustrating that concept with this very simple metaphor. There are other things you can do which I think are also very exciting when it comes to that opportunity to go I'm talking about the science, but I have all of these visual tools at multiple levels that I can bring to bear. So here's a nice example of something that I don't even know what to call this. I have the environment that they're in resonate with the conversation. So they're talking about, actually on a slightly earlier page, they're talking about the whole concept, which you may have heard of. One of the ways to get to the multiverse concept is through the idea that in quantum physics you're presented with choices, and there's probabilities as to which choice, if you like, the universe makes. And going all the way back to Everett, there was a suggestion that maybe all of those different choices do take place, but they're in different universes. And so we're only in the one universe, so we only ever see one choice. Whether or not that's right is not the point of the discussion. The point is that it leads you to, it's one way of leading you. It's not the only way, and sometimes it gets conflated with some of the other ways, but it is one way of leading you to the concept of a multiverse. And so while they're talking about this branching phenomenon, it's a little on the nose, but I do think it's helpful to resonate sometimes with the idea visually. And so here we have branching, and so it's, like I said, it's a little on the nose, but I think can be very powerful when you're bringing everything to bear to immerse the reader in the story and have all sorts of different ways that they can latch on to what the ideas are going past. Here's a different thing that I do in a different story. Well, first of all, let me take a step back. Something I think is not done enough in science books is talking about the process of science, not just the gee whiz facts, because the process is the thing that's certainly going to be invariant over time, whereas facts can get updated and things like that. So it's very important to understand the process of doing science. And yes, there's a lot about that in the literature. There's not so much, I would say, in the literature of theoretical physics. I think what we do is often a little bit of a mystery. And so I came up with the idea of what I think is a really great analogy to the process of doing theoretical physics, and that's doing jigsaw puzzles. And so actually, so these two characters actually start talking about that. And again, because I can work on many levels, they're sitting at the table in a cafe, but now all of a sudden they're using jigsaw pieces, and they're talking about what do you do when you try and solve a jigsaw puzzle. And you do things like you try and sort of turn them all over and see what all the different things are. So you're looking for more examples of things that might fit together. That's something we do in theoretical physics a lot. I would say we spend most of our time doing that. But you're also trying to see what things might have in common. So you group all of those shapes over there because you think they've sort of got bits of blue in them, so they're probably going to be the sky. Later on, you'll find some of them's the surface of the lake, but for right now, maybe that's a red herring. But you start to classify things. You look for special cases, sort of edge pieces, corner pieces, things like that. This is exactly what we do in theoretical physics. So that analogy I play with a lot. And then there's something which I thought would be fun to play with, where I actually play with the form of the graphic novel itself, the panel structure. Right, here are the different panels. You're seeing here at different times. And the way I've pointed the shapes takes you a non-traditional way around in the reading direction of the panels, and she's talking about that business of turning and finding and turning over pieces, finding new pieces, trying to put them together. But sometimes you get stuck. You either put a piece wrong somewhere or whatever, but the point is that some pieces don't match. And so I actually have that resonate in the structure of the panel. Something went wrong, and I can't make the connection there. So that's sort of a fun thing. Again, having now not the environment, but the actual structure of the page itself resonate with the idea that's being discussed. So I want to also just have fun with crazy metaphors that are just, why not? And so this is a discussion about the important concept of spontaneous symmetry breaking. The fact that the universe was much simpler as we go back in time. The universe becomes simpler and simpler and much more symmetric. To the point that actually, with all of that symmetry, the universe actually wouldn't be able to make interesting stuff like us. So actually, to make interesting stuff, you have to break those symmetries. And so one of the characters says, well, maybe that's a little bit, there's a little bit of a Milton-esque aspect to that, Paradise Lost, where Satan finds, the keys to the truth of the universe, which is symmetry breaking, and breaks the symmetry, and he's cast out, he's broken God's perfect universe, that sort of thing. So it's a fun tongue-in-cheek discussion. And so again, you can do that all on the page while still having the conversation take place in sort of real time. And again, that multi-level way you can do it, partly because as a reader, you can take your own time to analyze that and absorb that multi-leveledness, which you wouldn't be able to do if it were a movie. That's an incredibly powerful aspect of the medium. Let me say a little bit about methods, because like I said, I didn't just go, oh, it should be a graphic novel, and then just draw it. I had to actually learn how to draw. So the key thing here is, the key thing is practice. The point is that, like most people, I would doodle, I would maybe try and sketch faces, try and get good at a face, but you always end up doing that same face. It's that one face you can do really well, what have you. That's not going to work if you're trying to have a range of characters. You're trying to do 200 plus pages. You want that character that started at the beginning of that story to sort of look like the same character at the end, so you need consistency, and most importantly, you need speed. You need to be able to do thousands of drawings and reasonably consistently. So I just had to really improve and just teach myself how to draw, for real, as it were. So, but a lot of it has to do with practice, and if you like, intentional practice, and using every opportunity to practice. So I just started, this is not just starting, this is maybe, I probably shouldn't show you the really early stuff, but at some point what you start doing is studying human anatomy, studying faces, using every opportunity to just draw. It's actually a wonderful thing. Whether you use it for anything or not, it's a wonderful way of seeing the world with new eyes. When you start figuring out how to draw things, you start figuring out how to look at things, and you look at familiar things anew. And it's really a truly wonderful thing. So, if you're looking to take up a new hobby or something, just carry a little sketchbook around with you and a pencil, and you get a spare moment and grab someone's face on the subway. I mean, not literally, but don't do that. As a drawing, this is a lady I saw on the subway. I think I drew that on my iPad, and just opportunities. And then I was learning many different techniques and perfecting, and I still do it today, just whenever I get the opportunity, try and do a drawing. It's a learned skill, despite what people tell you. They like to say, you either have it or you don't. Strangely, they often say that about science. That's wrong. These are all learned skills that you can perfect. Drawing buildings, fun and very, very useful skill as well. So I was practicing a lot of those sorts of things in preparation for then embarking on the graphic novel. And even after I started doing the graphic novel, I was still learning. And if you look carefully, you'll be able to figure out which stories I drew in which order, because certain techniques got improved. I use a mixture of traditional media and, for example, here I'm learning how to use brushed ink to work on this drawing, and also, as I said, digital media. I also use traditional. I'm very old-fashioned, and I love getting rulers and T-squares and pencils and what have you, and constructing ridiculous amounts of perspective, and then, but also sometimes I would do stuff where I speed up a lot of that process on a computer. So I was using all sorts of techniques. Here's again traditional inking, but now with more modern pens and things like that. So that was a fun adventure. And like I said, I was at the beach with my family in just last year, and again I had the opportunity to do a quick sketch, and it's just fun to keep those skills alive. So that's probably enough examples. What else? Yes, process. So what I've done, and you can find some of it on my blog, but also out in the reception, you'll see I brought some process drawings, some of the original art, which you might, if you like, have a look at. Here's some examples where you actually see, because there's an important question about how does one actually write a graphic novel? How does one actually do this? And the whole point of me spending time learning the skill of doing it myself is because I really believed, and I strongly do believe, that while there's nothing wrong with collaborating with an artist and telling them what you want to draw, I think certainly for this, I felt that the project would be vastly improved, and I would be vastly less frustrated if I could just do it myself rather than having to translate it to an artist. So, but when one's creating, what does one do? Does one write the whole story and then draw it out later on? And sometimes I did that, but I think the most successful use of the medium is when I was very rapidly thinking in pictures, thinking in terms of how I'd want to depict things immediately, and that would help also drive the story as well. So you end up with the story, with the science embedded in the DNA of the storytelling if you can draw as well as write at the same time. So this actually was maybe an 1.5 by 1.5 little thumbnail of a sequence that I was thinking of, and it eventually became this page. I just blew this up so you could see it, and this is, of course, a much larger page. And I'll talk a little bit more about this, but, well, I'll talk about it now. It's actually, there's a little boy, a young boy, sitting in the kitchen reading a book, and he looks over and he's watching his mother cooking some rice, and then he notices something astonishing for the first time, and he then begins to wonder why. And that ends up being a wonderful conversation between him and his sister about essentially the science of cooking. And so there's a chapter on that. So people often wonder, where's the string theory and the stuff like that and all of that, and there isn't any. But I would say all of science is in that one story. It's one of my favorite stories, if I have to betray a favorite, because he makes an observation. He has a hypothesis about why that thing took place, and then they design an experiment to test it. And that's all of science in microcosm right there in that story. Anyway, let me move on. Here's some other examples. This is just, people often mix the superhero genre up with the comics form and conflate the two. They're not, and sometimes that can be annoying. But nevertheless, I couldn't resist having a little bit of a nod to superheroes. So there's a conversation in there about that trope that scientists. You may or may not know that there's a lot of those famous superheroes were actually scientists. The Hulk and Spider-Man was a kid interested in science, and so on and so forth. And then an accident happens, and they go off and fight crime. And one of the discussions they go is, well, is that what would really happen to a real scientist, or would that help you do your science better? And so they have that discussion, and so here's sort of contrasting that aspect. And it's an opportunity, again, in a conversational way, to explore some scientific ideas in a fun way, I hope. And finally, here's one last example. This was a sketch that ended up being this sequence here. They're actually discussing the whole business of whether certain concepts in mathematics exist in the world, or whether you can only ever find the approximation. And so they use the example of a circle, and he's exploring better and better approximations in his mind by just walking along and encountering more and more circles. So that's, again, a sort of visual way of, through narrative, drawing you into that concept. Okay, so I'm going to end with one last thought. Well, maybe two last thoughts. People often ask me, and this is common when you have a someone who's an expert in one area who goes and dabbles in some other area for a while. And people always ask, well, what amazing thing did it help you discover? And I think people are hoping that I'm going to go, oh, yes, I found these amazing equations, or I revolutionized string theory because I was drawing comics. I'm sorry, I can't tell you that, because that didn't happen, although maybe it will one day. But that isn't the only reason to do this. I would say it's extremely important to realize that trying to find ways of explaining concepts about your field to others is incredibly enriching. It makes you understand what you're doing way better, and so it ends up feeding into not just your teaching, but also potentially your research. So it's not an exciting, sexy answer that people are looking for, but that's the truth of it. However, this next bit is a little tongue-in-cheek, but there's a serious note to it. I like to say that I did discover an equation, and I'm going to share it with you now. And the equation is comics equals physics. So what does that mean? Now, if you study some of those books I mentioned earlier about how comics work, or how to read them, or what have you, they all will tell you something very important, so this isn't original to me. It's the fact that comics are not a passive medium. And it's a wonderful thing. It's another reason I think it's incredibly powerful. You, the reader, are involved in helping the comic work in the following sense. So a comic is a bunch of stills, and a convention for how to read them. So I look here and I see this character in green here, and and there she is there, and there she is there, and I've assembled this thing. And in your mind, you're immediately creating the space that she's moving through. I didn't do that just as 3 images, but you already have maybe even a 3-dimensional sense of what that space is. You created it yourself. Also, you've broken this up. Without even me telling you to do it, you've broken this up into time steps. You know that this is earlier than this, and so on and so forth. So you create space and time as you read the comic. You're an active participant in that medium. What does that mean? Well, for me, and this is my comics equals physics statement, I would say, what better medium to discuss the science, which is largely about space and time, right? Physics. It's all about, what happened when and where, and all of that is about being in space and the business of space and time. And a lot of the discussion in this book is about the nature of space and time. And so I would say that actually comics are not just well suited to physics. I would say in some sense they really are physics on the page coming alive with your assistance as the reader. So this is why I think it's incredibly powerful. Here's another example. This is what I was saying. Earlier. He watches. You're looking at those different panels, and you're creating time by reading them in that order and seeing that she's doing what she's doing at the stove there. Okay. Once I really fully understood that was going on, rather late in the process, I realized, oh my goodness, I should play with this. I should have fun with this. This is another thing I can do. So here we are. That concept I was telling you about space and time itself maybe breaking down at the quantum level. They're discussing it at this point, and the panel structure, which is, of course, the space and time of the book, the panel structure itself begins to break up. And I get to play with that, and it spills over onto the next page. So it's a great way, again, of having some resonance with what's just being talked about on the page in another way. And as a final example, this is a discussion. There are 2 people discussing ideas about what may happen inside a black hole. And one of the things that Einstein's equations tell us, which may or may not be right, because they don't have the quantum component yet, is that when you go inside a black hole, what you thought was space and time on the outside get mixed up. Something goes wrong with them in an interesting way. So I actually resonate with that. I resonate with that idea here a little bit overtly. They don't actually say that explicitly, and I do it a little bit covertly, where as they're discussing going into the black hole, and this swirl of the brush here leads your eye around the panels in, again, a non-traditional order. Normally you'd read them 1, 2, 3, 4, but the speech and the swirl of the brush leads you down that way. And so I'm deliberately confusing you your space and time, which is the panel structure and the audio is supposed to read them in, as you swirl inside the black hole. So it's just me being playful, again, with that sort of core concept that we've learned about the physics and having it do some of that on the page. And I also mess around a little bit with what may or may not happen to the singularity at the core of the black hole. So there's a lot of things going on in some of these diagrams. I'm also a big believer in creating things that have a lot of structure. So you can read it one time and not get everything, come back, read it again, get some more. So you may not have seen that the first time round or even the 15th time round, but hopefully if you come back the 16th time, you go, oh, wait, yeah, time got messed up. So I like to embed that everywhere I can in the book. Okay, it's probably time to stop. So let me end by just saying what my hopes are for all of this. Hopefully not confusing you, hopefully exciting you, hopefully inviting you to eavesdrop on those conversations, but also to have conversations of your own out there, engage with the science. I know especially this audience probably already seeks out the science, but do try and either you or the book itself will maybe encourage others to just encounter the science in their everyday lives, look at the world differently, and just chat about things you may have heard about the science. Don't leave it to the quote-unquote nerds, and don't be embarrassed to be nerdy about it. It's just part of our culture like everything else. And so, thank you.
Well, let's open up the microphone to questions. So if you have a question, just pop up, form a queue behind, and that way I can get to as many questions as I can. And we can, as you make your way over, I'll go to an online question first, and then we'll jump to you. So the online question, here's an online question. What has the reception been to the dialogues among your physicist colleagues?
I think, so that's a great question, and it can touch on a lot of issues. Not everyone in the academic community, I don't just mean physics, are signed up to the idea of spending time talking to the public. Different people do it in different amounts, and some people don't do it at all, and some people think it's a waste of time. I think increasingly, things are shifting in what I consider to be a positive direction. I think more and more scientists of all ages are recognizing that it's hugely important to communicate with the public. I think there's still a lot of people who don't get why I'm doing comics, because they either think it's for kids or it's the Sunday funnies or what have you. But I think those that get it, or those who at least get an idea that I'm at least trying to innovate, trying to expand what we offer people, I think those people do largely encourage it. And I think there are also colleagues who are wildly enthusiastic, who are trying things themselves. So I think I have the full spectrum of responses, but it's overwhelmingly, I think, in the positive camp versus the negative camp. Maybe, the negative people just don't tell me what they think.
Very good. Let's go in the theater.
You mentioned that when you try to explain things, sometimes you learn yourself something. And I guess when you write your cartoons, you also sometimes learn something. Do you have an example?
Oh, gosh. Well, so a lot of the learning is learning better ways of explaining the idea. But sometimes I'm trying to think of a good example. Actually, I'm sure there is one, but right now it's not coming to mind. Where I began to look at things quite differently. I can't quite put my finger on it, but let me put it this way. And if I think of it later on, I'll come back to you. The core thing I think that I think has been very useful was I always thought about things quite visually, I have to say. And you'll find scientists in my field, there are some who are very visual right at the outset, and there are some who are much more sort of algebraic, if you like. And so I've always been more on the sort of visual side, if you like. But I think, and if you look through my notebooks, you'll see a lot of my ideas are driven by sketches in various ways. I would say that finding more and more efficient ways of using those sketches as placeholders for powerful ideas that communicate back to the physics, I think I've gotten better at that as a result of doing this kind of thing. I could be more specific about examples, but I would say a lot of it has been refined, but was already there as part of my toolkit. But I think it has overall benefited me greatly to do more of it and try and make it clear to others. Hope that's helpful.
All right, I'll jump online and then we'll come right to you. An online question here says, I read that you were a science advisor on movies like Thor, and I'm not going to say the second part of that movie name because I'll destroy it, thank you. What did you advise on?
Within that movie?
Yeah.
Right, yes. So it's out now, so I think the non-disclosure agreements are null and void. So, and also a lot of my colleagues go, why are you messing around with crazy concepts with people with magic flying hammers and so on and so forth? Clearly there's no science there. There's a whole talk to be had about the whole process of science advising in movies and TV and how you go about doing that. But let me not go there. The key thing, I think, in Thor that I really had fun with, and I think Taika Waititi had fun with as well, was, that's the director, was the idea of trying to find more ways of visualizing some of the astrophysical objects that they encounter in that movie. It's a very sort of space adventure-y sort of movie, and one of the things they encounter is a set of wormholes. There's a planet that is sort of the exit point of many, many different wormholes. And wormholes are a fun concept to play with in theoretical physics. People love them in fiction. They're great devices for writing because you can get from one place to another fast, which is what happens in Thor. But you might ask, what would they look like if they interacted with the atmosphere as they do with that planet? So I gave them a lot of advice, some of which they took, some of which they didn't. That's how it works. And to have those wormhole entrance and exits look interesting. And then the other thing which I told them a lot about, which also fed into the Infinity War movie, the Avengers movie, is the whole business of how Thor's hammer, where it comes from and how it was forged. And there's been this long discussion going back to early Marvel comics where people conjectured that, well, this incredibly heavy thing, it's supposed to be, maybe it's made of some incredibly dense material. So it's an opportunity to have some words spoken by our scientist characters, which I helped give them, talking about that maybe it was forged in, I think there's a phrase where it says that it was forged in the dying embers of a dead star, which is a neutron star, which is a real thing. And there is an incredibly science fiction-y sounding density to that material. And so the idea is that you forge Thor's hammer, because the Asgardians have extraordinary technology, they can forge and somehow contain that density into this amazing weapon. And they follow up on that in Infinity War, which I also advised on, where you see the forging of a new weapon. Spoiler. No, it came out last year. We're okay. Yeah.
Thank you. In the theater.
Hi. I learned some things tonight. I did not know that Galileo's text was written in a dialogue. Made me think of the early Greek philosophers like Plato and, Socrates.
Right.
What's the relationship, or when did we shift these different forms of thinking of scientific thought between philosophy, science, and where does graphic novels fit? What is the relationship between these three kind of things?
Oh gosh, that's an interesting question. I suspect the book connecting, especially that last connection, probably hasn't been written yet. The first connection is more straightforward. In some sense, physics, of all the sciences that we think of now in the modern context, has its most natural connections with philosophy. And so I think Galileo already recognized that and did his bit to sort of resurrect the form so he could talk about the physics of the day, although it wasn't called physics yet. But physics, the earlier term for physics was actually natural philosophy. And so there's a straight, bright line between Plato and Socrates and many other philosophers from that time, and then the modern natural philosophers who are what we think of as the physicists. Going from there to dialogues in comics format, well, that's this, and I don't know. I don't know other than the fact that I'm a physicist, so I know about that other history, and now I'm bringing it to comics. That's, as far as I know, the only connection. I'm not aware of there being other comics about physics in dialogue form. Whether there are other comics in dialogue form, that's possible. I mean, in that deliberate sort of way of illustrating through dialogue, that's possible. I do not know of one, but I wouldn't be surprised. The comics world is huge, and there are many examples of all kinds of innovation. So it is possible that there's a history of dialogues in comics I'm not aware of.
Let's take one last question from in the theater.
Sure. Just a variation on it came to me when you were talking, but I'm interested in, say, the pursuit of excellence. So that you said that you have sketchbooks and that. How much effort and time did it take you to get to the level that you would publish? And the subsequent question was, considering that you were working in Marvel, did anybody from Marvel have, and they had interesting fractures of time and space in some of their comics, give you any suggestions to help you with your work?
No, well, great questions. Let me before I forget, let me address the last one first. The Marvel people doing movies really have very little to do with the comics. Occasionally, you will find some of the people involved in the movies maybe read the comics when they were kids, or as grown-ups, or maybe as reference for making the movies. But really, they're not necessarily very interested in comics, although you will find many examples of some of them who really love comics. But they're really trying to use it as source material for making a film. And so oftentimes, when I'm talking to filmmakers or special effects people or what have you, writers, directors, what have you. Sometimes I'm the person who knows most about the Marvel comics in the room because I grew up reading some of those things, and so sometimes I'm telling them stuff, trying to. It doesn't always work, but sometimes I'm trying to suggest that they do winks to some of the comic stuff and embed that in the movies just for fun. It doesn't always work. So particularly sometimes a lot of the science content that they don't realize has been around in the comics for a long time. But in terms of the sort of business of time and space and how to depict it, what have you, usually that's what I'm bringing to them. Although I would have been very open if they had suggestions. But when I go and talk with them, I'm not talking about my comic project. So I don't think any of them ever knew what I was up to when I was making the book. So moving to the question about drawing, it's an ongoing process. I think by the time I just finished the book, I think I really sort of arrived somewhere where now I could, I really sort of fully got it. And so in some sense, it's sort of, no, I should do a second volume because now I really understand what I'm doing. So there was always that process of evolution. As I was drawing, I ended up redrawing an entire sort of that prototype chapter that I did that I was happy with in 2012. By the time I got to 2016, I couldn't look at it anymore. I had to redraw the whole thing, and so on and so forth. And probably there'll be a time when I look back at this and there's some things in there I'll just sort of go, I hope, yeah. But it's okay because I think it's a process, and if it does the job, that's certainly a bar that you want to cross, and then anything beyond that is icing. One of the key things I said, and then I'll probably stop talking, is you practice, but you practice intentionally. So you're observing yourself, you're trying to see where your weak points are, and you're pushing on those things. You're always looking at other examples, if you can, other artists. The web is great for that, because there's just thousands of artists sharing their work, sharing their process, sharing their methods, sharing their tools. You get what you can. One thing I really got into a lot was collecting how-to drawing books. Because basically there's a huge number of people who get to a point, they get really good at it, and they go, I'm going to write a book. This is going to be the method. This is the method. And of course, it's never the method. But as you learn how to draw and you learn what works for you and what doesn't, you know how to go to those books and sift through all the nonsense about this is the ultimate method. But there's maybe some things you can take away and build into your own methodology. So it's just always, it's practicing, not buying into the nonsense that it's some magical gift that some people have, and really realizing that there are learned skills, there are learned ways of looking at things. There are constructional crutches you can use while you're learning that skill that can improve. And then it just never stops. So it's infinitely rewarding as well, because you can really sort of see improvements probably all your life.
Thank you.
Ladies and gentlemen, Dr. Clifford Johnson.